Hello students, good evening students. Today I am explaining you one of the important area, that is GOC, General Organic Chemistry. To most of the students, General Organic Chemistry, they are feeling like fear. It is most of the students, it is like a phobia. General Organic Chemistry, but this is one of the most important topic for understanding first year and second year organic chemistry chapters. GOC area is one of the important area, and also it is a weightage in our NEET examination point of view, JEE mains point of view. It is a weightage area. So in the general organic chemistry, one of the important area is this electronic effects. Electronic effects, this is most important area. So electronic effects, complete name is electron displacement effect. Displacement effects. The electron displacement effects, displacement means in the carbon chain electron density is moving from one carbon to another carbon. That is nothing but electron displacement. But this electron displacement affect two types, that is permanent effect and temporary effect. In the temporary effect, electromeric effect is comes under in temporary effect. Electromeric effect. Permanent effect, in the permanent effect the topics are inductive effect, resonance effect, and resonance effect another name is mesomeric effect also. Mesomeric effect, and another effect is hyperconjugation. So what is the use of these effects? These effects explains to the carbon chain. If you are noticing the carbon carbocation stability, carbanion stability, free radical stability, acidic strength, basic strength, which resonance structure is the more stable resonance structures, those kind of properties are explained by these effects. These effects are very useful understanding the whole organic chemistry, basically whole organic chemistry. So each topic detailedly with examples and applications I am explaining now. First one is inductive effect. What is the inductive effect? First example is the first one is inductive effect. What is inductive effect? What is inductive effect? A simple meaning I am telling here. Displacement of sigma electrons in carbon chain. Displacement of sigma electrons in carbon chain is known as inductive effect. Displacement of sigma electrons in carbon chain, what is the meaning of that? For example, here the carbon chain is present. The carbon chain between the carbon atoms, sigma bond is present. The sigma bonding electrons existing exactly centered to the both the carbon atoms, doesn't move this atom side, doesn't move this atom side, because of both are same electronegative atoms, both the carbon atoms. All the electrons existing exactly centered to the both the carbon atoms. That is not displacement. No displacement of sigma electrons. For suppose this carbon chain is connected to the different electronegative atom compared to the carbon. For example, oxygen is connected to the carbon chain. Carbon and oxygen, which is more electronegative element? Electronegativity, oxygen is more compared to carbon. So due to more electronegative in nature, the bonding electrons moving towards the oxygen direction, because of electronegativity of the oxygen is more. So the bonding electrons moving towards the oxygen means which electrons? These electrons, sigma electrons. Displacement of sigma electrons in the carbon chain, that is called as inductive effect. Basically, that is a simple definition. But here inductive effect is two types: plus inductive effect and minus inductive effect. What is plus inductive effect? What is minus inductive effect? Look at plus inductive effect meaning is, for example, to the carbon chain, alkyl group is connected. Alkyl group means CnH2n plus 1. Methyl. In the place of N, take it as a 1, that is methyl. In the place of N, take it as a 2, that is ethyl. If alkyl group is connected, or alkyl group or oxygen, more electronegative element with negative charge, more electronegative element with negative charge, the connected to the carbon, the electron density moving towards the carbon side. The electron density, for example, oxygen is connected like this. Oxygen having the extra electron density, that is negative charge, electron density moving towards the carbon chain. So what happens before and after electron density on the carbon atom is changes because of the electron density moving towards the carbon chain, because of oxygen having the excess of electron density. On the oxygen, negative charge is there. Negative charge releases this electron density to the carbon. So what happens here on this carbon? Negative charge is generating. That negative charge we are representing as a partial delta. That is symbol is delta. Partial negative charge. More electron density is existing on this carbon compared to this carbon. This carbon having less electron density, that is double negative charge. This carbon compared to this carbon, less electron density, that is triple delta negative charge. Here more electron density is present, less electron density is present because of it is nearer to this oxygen. So it is gains the more electron density compared to this carbon. So if the group of atoms, that is alkyl group or more electronegative atom with a negative charge connected to the carbon chain, they giving the electron density. They giving the electron density to the carbon chain. Giving the electron density to carbon chain means they are losing the electron density, that is positive. The meaning of the plus indicates they are losing the electron density, that is generating the positive. But on the carbon, negative charge is generating. So which groups or group of atoms gives electron density to carbon chain. Electron density to carbon chain. Those groups are simply called as plus I groups. Plus I groups. So alkyl groups are plus I groups. They are releases the electron density to the carbon chain. A more electronegative element with negative charge, they are also releases the electron density to the carbon chain. Remember, alkyl group is the plus I group. Which groups are considered as, what is a minus I effect? For example, here to the carbon chain, more electronegative atom, group of atoms with neutral form, there is no charge here. More electronegative atoms with neutral form, there is no charge, connected to the carbon chain. Due to more electronegative in nature, they withdraw electron density towards itself side. Withdraw electron density towards itself side like this. This carbon is nearer to this oxygen. So what happens? This carbon gains, loses more electron density, more positive charge. This is less positive charge. Here less to less positive charge is existing on this carbon because of this carbon is far away to the OH. Which carbon is nearer to this OH or RH2? They loses more electron density. Which carbon is nearer to the more electronegative atom with negative charge, that is gains the more electron density. This is plus I effect. This is minus I effect. Minus I effect. Why? Because on the group which charge density increases, electron density moving this direction means here the negative charge is increases on this. That's why they are called as minus I groups. Which groups are considered as minus I groups? Which groups connected to the saturated carbon chain within in neutral form, OH, NH2. These groups are simply considered as minus I groups in the neutral form. Remember that, neutral form. But what is the use of the inductive effect? What is the use of the inductive effect? Inductive effect use is, it is explains the some properties of the saturated systems. Some properties of the saturated system means, to the saturated system, carbon having positive charge. The saturated system, carbon having negative charge. To the saturated system, carbon having the radical like that. It is explains the stability of carbocation, carbanion, free radical. So inductive effect is useful for understanding the stabilities of the carbocation, carbanion, free radical, and also it is explains the acidic strength, which is strong acid, which is weak acid of the aliphatic systems. That means especially saturated systems. Acidic strength of carboxylic acids and acidic strength of the alcohols, different compounds also. And also it is explains the aliphatic amines basic strength also. Aliphatic amines, not aromatic amines. So what are the applications are there in the inductive effect? In the inductive effect applications, the useful of the inductive effect is stability of carbocation, carbanion, free radical, acidic strength, basic strength. These applications are important in the objective way, both mains and NEET point of view. So the which applications I am explaining now. So inductive effect meaning is displacement of sigma electrons in carbon chain towards carbon or away from the carbon. Towards carbon or away from the carbon, depends upon the what are the groups are connected here. So application, first application. So application, first application, it explains the stability of carbocation. It explains the stability of carbocation. The use of the first application of the inductive effect is stability of carbocation. Carbocation, simple carbocation I am showing here. That is CH3 plus methyl carbocation. This methyl carbocation, first of all, what is the hybridization on the carbon? Methyl carbocation hybridization. Hybridization finding formula for cations. Hybridization finding V plus M minus C by 2. This is the formula for cations identification hybridization. V means number of valence electrons. Carbon, central atom is the carbon, group number is 4. Valence electrons 4. How many? M means monovalent atoms. Around the central atom, how many monovalent atoms? Monovalent means the atoms which are forms single bonds with the central atom. So this is hydrogen is a monovalent atom. It forms only single bonds. So 3. What is the C? C means a charge, cation charge, that is -1. Here the -1 by 2. So 6 by 2, that is 3. 3 means hybridization sp2. So carbocation hybridization is sp2. This is simple carbocation. Positive charge is there. So positive charge means electron deficient. It is a deficient. So stability, how to explain the carbocation? For example, this is ethyl carbocation and this is isopropyl carbocation. This is tertiary butyl carbocation. In these three carbocations, which carbocation is the stable carbocation? One carbon connected with one carbon. This carbon is the primary carbocation. One carbon connected to two carbons. This carbon is simply called as secondary carbocation. One carbon connected with three carbons. This carbon is called as tertiary carbon, that is tertiary carbocations. One carbon connected with one carbon connected with two carbons, one carbon connected with three carbons. This is primary, this is secondary, this is tertiary carbocations. So, which carbocation is the more stable carbocation among these three? This group is which group? Basically alkyl group. Alkyl group nature is, this is alkyl group, plus I groups. They are giving the electron density to the carbon chain, pushing the electron density like this, electron density. So here one pushing group is connected, here the two pushing groups are connected. So more pushing groups are there. Here one pushing group, two pushing groups, here the three pushing groups. So electron density on the carbon, positive charge is present, electron density is needed, number of pushing groups increases, electron density moving towards the carbocation side. So positive charge density decreases, stability increases here. So stability order, if you are noticing 1, 2, 3 comparison, 3 is more stable, after that 2, then 1. Why 3 is the more stable carbocation? Some number of pushing groups are more, plus I group, plus I group, plus I group. So plus I groups increases, stability of carbocation increases. Stability of carbocation increases because of deficiencies decreases. Deficiencies decreases. Look at another application, the line form. Carbocation. Here the carbocation. Here the carbocation is present. The line form I am represented here. In these three carbocations, which carbocation is the more stable carbocation? What I said here, one carbon is connected to another carbon, that is primary. One carbon connected to two carbons, that is secondary. One carbon is connected to three carbons, that is tertiary. Here in the first example, this carbocation is connected to two carbons. This is secondary carbocation. This carbon is connected to three carbons. This is tertiary carbon. This carbon is connected to one carbon directly, that is primary carbon. So carbocation stability order 3 degree is more, after that 2 degree, then 1 degree carbocation stability order, because of 3 degree carbon connected with 3 alkyl groups. Pushing nature is more. Here alkyl group, here alkyl group, here alkyl group. Pushing nature is more. This pushing nature, because of this pushing nature, stability of the carbocation, electron deficiency at carbocation decreases. Here two pushing groups, here one pushing group is there. So plus I groups are increases, carbocation stability increases. Another application.